Homework for B, lesson 4.8. Draw any polygon, scale it by 2 using the ratio method. Let the center of the dilation be as given. Part A, outside a polygon. So part A, you can make any polygon you want, and then you have to have the polygon, the center of the dilation outside. So that's part A, and you're gonna have to scale it. That's the original way of doing it, right? So if you get the distance from here to here, you double it, and from here to here, you double that. From here to the other point, double that. From the fourth point, double. From the fifth point, you double that, and then you connect it. You should have the same one, right? Should. And part B, asking you to, instead of having the center of dilation not outside but the inside, so whatever the polygon you get inside of it, so you draw a ray to hitting all the corners, and then make the distance from here to here, double that, from here to here, double that, from here to here, double that, and then from here to there, you gotta double that. So if you connect those, you should get the same thing. Don't use my polygon, but you can use the other polygon. On the polygon means, let's say you have another polygon like that. What if you have a polygon on the line? So again, you gotta hit all those vertex and double the distance. So from here to here, double that. From here to here, sorry. You gotta double that. Double that. Maybe that wasn't a little bit more than double. Double that. Double that. Alright? And then you connect it. Something like this. How about the last one is explain how the location of the center of dilation affects the scaled copy. How does that affect? Obviously we've got, depending on the place of the center of the dilation, you got the difference. You've got the same figure, but you got the in the different places. Well, that's actually almost the answer. Problem number 10. Draw a polygon, make a scale copy that share a vertex with the original. Use any scale factor you like other than 1. So problem number 10. So instead of let's have any figures, let's have a dilation, a center of dilation in the corner, any corner you want. So like that, and then if you want to use the factor 2, you double that. If you want to use the factor of 3, for example, you got to triple that, right? So that's going to be there. So if that's A, that's going to be A prime or A double prime, or you can make it shorter. You can make it half if you want, or you can make it 1/3, or you can make it 1/4, and so on and so forth. Problem number 11. Draw a polygon, make a scale copy that has one side containing the corresponding side of the original. So it's very similar problem with problem number 10, but if you get the figure, you're going to have to decide, you got to take the center of the dilation on the line so that you can share that. So let's say if I take the dilation midpoint, then you got to double that, you got to double that, then you got to double that, you got to double that, and then you get that. Make sure to use your own figure, don't use mine. Problem number 12. Julia scaled the polygon 3 times. The first scaled copy was closer to the center of dilation than the original polygon. What can you say about the scale factor? So problem number 12. The first scaled copy was closer to the center. So if you got the original figure like that and the center of let's say center of the dilation inside the figure, the other figure is actually closer to the center of the circle. So what can you say about the scale factor? So obviously the figure is smaller, so you can say something about that factor. So part B, the second scaled copy was farther from the center of the dilation than the original polygon. So what can you say about the scale factor? So for example, what number would you use to make this actually happen? Problem number, part C, the third scaled copy was the same distance from the center of dilation of the original polygon. What can you say about the scale factor? Be careful. So, for example, what number would you choose? You know, is that the only number you can choose? So that's the second one is actually bigger. So this is the original one, right? And the third one is actually the same thing. What's the scale factor? What could be the scale factor? What number could be the scale factor? That's problem. Problem number 13. If you use the parallel method with geometry software, you can make a whole series of different size scaled polygon, and you do not have to start from scratch each time. The next exercise describes how to do it. Use geometry software. So this is actually not really a problem, but the exercise. So we should probably do that in the class as well. So use geometry software. You can access to GeoGebra. That's a free software online. And construct a polygon in the center of dilation. Construct rays from this center through the polygon's vertices. Then place a point anywhere along one of the rays. This will be a slider point. It will control the amount of dilation. So maybe we should do the problem number 13 together. Problem 15. So that's 15. One figure is made of segments. A second figure is made of segments and carved parts. Why is the first figure easier to dilate? A. You can easily move the center of dilation of the first figure. B. You only have to dilate the endpoints of the first figure's segments and then connect those points. C. It is easier to place the center of the dilation inside the first figure. D. You cannot dilate the curved parts. So which one is the correct answer? Common sense will probably tell you.